Good morning, everybody. Today is Thursday, December 7th, 2017, and this is Before the First Cup with Jules here on UCY.TV. Happy Thursday, everyone. It is a chilly 32 degrees with ice and snow here in upstate New York, and the lake effect machine off of the Great Lakes has started, so it should be an interesting next couple days. So where do we leave off on Tuesday? We titled the show Brain, Light to Sound, Terahertz, AI Mood Implant, and Quantum Wars. We took a look at how frequencies, light, and sound, as well as electricity with transcranial stimulation, can affect some of the functioning of the brain, flipping switches on and off and being able to modify behavior. Yesterday was Wednesday, and actually wasn't feeling too up to doing a show, so I ran a rebroad. It was back from 2016, but it just by chance happened to fit perfectly in with what we'd been talking about on Tuesday, and that was titled Death, Physics, Energy, FCC, 5G, Internet of Everything, NSA, CIA, Google, and Skynet. And that took a look at some of the different ways that they are manipulating physics to be able to not only manipulate biology, but to be able to spy on everything we do. So on Tuesday, we ended the show looking at a program that DARPA has been working on, and that would be to turn molecules into a form of storage. Of course, as all kinds of 24/7 surveillance is going on around the globe, they are going to need to find better, faster, larger means of storing and processing all this data that they are accumulating. Well, there was another story. We'd only read one, but there was another story that actually came out of DARPA.mil that announced this program, and I want to read this to you. And the reason why this bothers me so much is because when we listened to Ben Goertzel talking about artificial general intelligence, he had actually kind of joked about hopefully that the AI would not turn us and our molecules into some sort of storage device. Well, it looks like DARPA is figuring out how the machine could do that. So this is out of DARPA.mil, turning to chemistry for new computing concepts. DARPA explores approaches to store and process vast amounts of data using encoded molecules. As the complexity and volume of global digital data grows, so does the need for more capable and compact means of processing and storing that data. To address this challenge, DARPA has announced its Molecular Informatics Program, which seeks a new paradigm for data storage, retrieval, and processing. Instead of relying on binary digital logic of computers, and that would be zeros and one, based on the von Neumann principal architectures, molecular informatics aims to investigate and exploit the wide range of structural characteristics and properties of molecules to encode and manipulate data. It's pretty much what it is sounding like to me is that they are trying to find a way to create some sort of digital DNA that is encoded with information, just like our own DNA is. We had read quite a long time ago about them tinkering with storing information on DNA and then encasing it in glass. And actually, I found that story, which will allow them not only to miniaturize huge amounts of data, but also to have the ability to store that data for millions of years. Chemistry offers a rich set of properties that we may be able to harness for rapid, scalable information storage and processing, says Ann Fisher, program manager in DARPA's Defense Sciences Office. Millions of molecules exist, and each molecule has a unique three-dimensional atomic structure, as well as variables in shape, size, and even color. This richness provides a vast design space for exploring novel and multi-value ways to encode and process data beyond the zeros and ones of the current logic-based digital architecture. Molecular storage concepts, such as those based on DNA, ding ding, have advanced in recent years and show promise for archiving digital data in a format that takes extremely small physical space, says Fisher, and maybe they could use some of these molecular storages on things such as smart dust, and we might look at some of that today. But DNA storage does not allow for the rapid retrieval and processing of selected portions of the DNA encoded data without first having to decode the molecule back into an electronic digital format to use with existing information systems. The primary technical challenge posed by molecular informatics is the integration of dense storage concepts with processing of molecule-encoded information via completely new non-binary information structures. The intent of this program is to explore such opportunities in the much broader design and encoding of millions of molecules. Yeah, wasn't this one of DARPA's molecular BTO programs that they had, the Living Foundries, which offers far more opportunity than do with the 4 building blocks of C, A, T, and G of DNA. To achieve its goals, the program will require diverse, collaborative communities of researchers from fields including chemistry, computer and information science, mathematics, chemical and electrical engineering as well. And these integrated teams will need to answer questions about the foundations of such things such as how can data be encoded in molecules, what type of data operations can molecules execute, and what does computation mean in a molecular context? By addressing mathematical and computational problems that challenge our current capabilities, the Molecular Informatics Program aims to discover and define opportunities for the use of molecules in information storage and processing. Fundamentally, we want to discover what it means to do computing with a molecule in a way that takes all the bounds off of what we know and lets us do something completely different. And this is going to be making like biohybrids. And that is what we absolutely need to diversify the knowledge of our many different fields working together and to jump into this new molecular space that we see so we can see what we can discover. There was a webinar held in April of 2017, and we could go out to fedbizops.org and see what we could find. So let's get to DNA storage. DNA storage could preserve data for millions of years. This is from 2015. We covered this quite a while ago, but I thought it was worth mentioning again. Taking inspiration from fossilized bones and how they can preserve genetic material for hundreds of thousands of years, researchers at the ETH Zurich have developed a synthetic fossil by writing digital information on DNA and then encapsulating that into a protective layer of glass. Most of our digital data is stored with technology that is designed to work in the short term, but which can't really stand the test of time. Standard hard disks won't last more than a few decades, unless, of course, it's a molecular one, and subject to damage from high temperature, moisture, magnetic fields, and mechanical failures. Even solid-state drives, which perform better and are less susceptible to mechanical issues, like flash, will lose their data if they go unpowered for more than a few months. One interesting solution could be to store digital data using strands of DNA. And as far-fetched as that may sound, there are a couple very good reasons that make this an attractive proposition. First of all, DNA can store information with a data density so high that it can be hard to fathom. And, you know, we talked about DARPA working on some of the synthetic biology, adding new X and Y neuropeptides or whatever they were called, and proteins. So instead of just having 4, they now have 6, which moves an exponential range of different organisms and products that they can produce. Well, nucleobases, that's what they call them. Well, just imagine now adding that X and Y with synthetic biology and then using those 6 nucleases to be able to store data on DNA. That would give them an exponential increase in their data storage. But for data density approaching 1 petabyte per cubic millimeter is what they have now within a single living cell. And add to this the fact that under the right conditions, fossils can preserve genetic material for millions of years, and you have the perfect candidate for long-term data storage. This is exactly what Dr. Robert Grass and the team at ETH Zurich is trying to achieve. As you all remember from high school biology, DNA is encoded by 4 nucleobases, meaning that each of them can, in theory, represent up to 2 bits of information. And after limitations dictated by the technical challenges of synthesizing and sequencing nucleotides, and with the addition of redundant bits, which make up about 35% of the total of the data, to protect against data corruption, and that's some of that striping I was talking about, the final data is an impressive 1.2 bits of useful data for each nucleotide. Dr. Grass and his team began to experiment by storing 83 kilobytes of information inside of 4,991 DNA segments, at least 158 nucleotides long. And then to protect the DNA from degrading over time, the researchers created a de facto synthetic fossil that encapsulates it in 150 nanometer silica spheres, which prevent the genetic material from chemically reacting with the environment. To read back the data, the nanospheres need to be exposed to a fluoride solution, which that's kind of weird, which dissolves the silica but leaves DNA intact. Digital systems, so fluoride dissolves silica? Do we have silicon on our teeth? I don't know. We'd have to look that one up. Digital systems, I know you get it in your skin. Digital systems designed to store data for a very long term usually aim for very high levels of heat resistance, and the reason for this is that generally accepted way to estimate long-term durability and data retention in the lab is to subject the storage medium to high levels of heat and see if it burns up. Encapsulating DNA in silica, i.e. glass, is specifically meant to provide that level of protection. In this case, the researchers simulated the degradation of DNA by exposing it to temperatures between 60 and 70 degrees Celsius, which is 140 to 160 degrees Fahrenheit, for up to a month, which replicated the chemical degradation that would have taken place over thousands of years. Current technology incurs a lot of mistakes while both writing and reading data from DNA, but the redundant bits that are written alongside the original data showed their use here. And after storing the DNA for a simulated 10,000 years in a fridge at 4 degrees Celsius, also 40 degrees Fahrenheit, about 80% of the sequences contained at least one error, and about 8% of the sequences were only completely lost. Still, due to the smart redundancy we have added by the Reed-Solomon coding, we are able to decode the data without final error. The scientists calculated that if the same data had been stored at even lower temperatures, such as minus 18 degrees Celsius, which is 0 degrees Fahrenheit, like found inside the Slavard Global Seed Vault, it would have survived for over 1 million years. The cost of manipulating DNA makes this currently unpractical for everyday use, but don't worry about it because it's coming. And advances in DNA sequencing are dropping the cost of reading stored data, and more research is also going into reducing the cost of writing digital information onto genetic material. We are currently looking into decreasing the cost of writing information into DNA into the first commercial applications in storing highly valuable information. We are also gathering more data on thermal stability to gain more promising understandings of how DNA decays chemically and how this can be further avoided. So as we continue down this path to reverse engineer biology for those who are puppeteering the global military industrial complex, which has got to be worrisome to some of you. I came across another story. I've had this queued up for a couple weeks now, but I didn't have a good place to put it, but this one is as good as any. Researchers develop a gel for growing large quantities of neural stem cells. Now remember, they're trying to reverse engineer the brain so they could build more powerful, more human-like artificial intelligences so they can put intelligence into everything that is around us. In many ways, stem cells are the divas of the biological world, and on the one hand, these natural shapeshifters can transform themselves into virtually any type of cell in the body. Remember those iPS stem cells, they can get right from scraping your skin, then they mix them up with some chemicals in a petri dish and bang, flip a few switches, and they can turn into almost any cell. In that regard, They hold the promise of being able to cure ills ranging from spinal cord injuries to cancers. On the other hand, says Associate Professor of Material Science and Engineering Sarah Hilshorn, stem cells are like divas, and they are also mercurial and difficult to work with. We just don't now know how to efficiently and effectively grow massive numbers of stem cells, like to make armies of little mini brain balls, and keep them in the regenerative state. And this has prevented us from making more progress in creating therapies. Until now, that is, and that is now a recent paper in Nature Materials. Hellishorn describes a solution to the dual challenges of growing and preserving neural stem cells, and that would be those of the brain, in a state where they are still able to mature into many different cell types. The first challenge is that growing stem cells in quantity requires space, and like traditional farming, so if we're going to have a stem cell farm, it is a two-dimensional affair. If you want more wheat, corn, or stem cells, you need more surface area. So culturing stem cells, therefore, requires a lot of relatively expensive laboratory real estate, not to mention the energy and the nutrients necessary to pull it all off. The second challenge is that once they've divided many times in a lab dish, stem cells do not easily remain in that ideal state of readiness to become other types of cells. Researchers refer to this quality as stemness. Hellishorn found that for neural stem cells that she was working with, maintaining the cell's stemness requires the cells to be touching. Hellishorn's team was working with a particular type of stem cell that matures into neurons and other types of cells in the nervous system, and these types of cells, if produced in sufficient quantities, could generate therapies to repair spinal cord injuries, counteract traumatic brain injury, or cure some of the most severe degenerative disorders of the nervous system, like Parkinson's and Huntington's disease. Hellishorn's solution involves the use of better materials in which to grow stem cells, and her lab has now developed a new polymer-based gel that allows the cells to be grown in 3 dimensions instead of 2. This new 3D process takes up less than 1% of the lab space required by current stem cell culturing techniques. And because stem cells are just so damn tiny, the 3D gel stack is just a single millimeter tall, roughly the thickness of a dime. For a 3D culture, we only need a 4-inch by 4-inch plot of lab space, which is about 16 square inches, and a 2D culture requires a plot about 4 feet by 4 feet, or 16 square feet, more than 100 times the space, according to the first author, Chris Medel, a recent doctoral graduate in bioengineering from Hellishorn's lab. In addition to the dramatic savings of lab space, this new process demands fewer nutrients and less energy as well. So, of course, they can make them faster, smaller, and requiring less intervention. This is how this whole biological integration with technology is happening. And the gels that the team have developed allow stem cells to remodel the long molecules and maintain physical contact with one another to preserve critical communication channels between the cells. It is the simple act of touching, and that is making a network connection, that is key to communication between stem cells and to maintaining stemness. If stem cells can't remodel the gels, and they can't touch one another, so the stem cells don't exactly die if they can't touch, but they lose that ability to regenerate that we really need for therapeutic success. So step right up for your stem cell injection. This need for neural stem cells to remodel their environment differs from what Hellishorn has found in working with other types of stem cells. For those cells, it is the stiffness of the gels, not the ability to remodel the gels, that is the key factor to maintaining stemness. And it is if for these other types of stem cells, gels must mimic the rigidity of tissues in which the cells will eventually be implanted. But not so with neural progenitors, says Hellishorn. So that's interesting, because we had looked before at them using sugar scaffolding to be able to print organs utilizing stem cells, whether you want to need a new kidney or a liver. They can print it right out and squirt. It's almost like an inkjet printer. It's a stemjet printer. And they can squirt out those particular stem cells onto the scaffolding and it would grow into the right shape. Well, it sounds like using neuronal cells such as a brain. It needs to be fluid, not rigid, to be able to grow and have the ability to regenerate properly. Neural cell stemness is not sensitive to stiffness, and that was a big surprise to us, she said. The result was so striking and unexpected that Helleshorn at first did not even believe her own results. The lab ended up testing 3 entirely different gels to see if their conclusion held, an unusual supplementary step in this kind of research. And with each new material, they saw that those that could be remodeled produced quality stem cells. Those that could not be remodeled had a negative effect on stemness. Next up on Helleshorn's research agenda is to create gels that can be injected directly from the lab dish into the body. Oh, God. The possibilities have her feeling optimistic about stem cell therapies again. Well, not me. I'd always said stem cell therapies was one of those mad science therapies that if I had to step right up, it might be one, especially if they're using my own skin cells to create the stem cells, that I might not be so afraid of, but not if they have some sort of synthetic polymer gel they're going to inject along with it. But 4 times, she says, it felt as if the field had hit a wall as initial excitement for regeneration gave the way to uninspiring clinical results. But with her new findings, she says, it feels as if new things may be just around the corner, and we should be afraid. There is this convergence of biological knowledge and engineering principles in stem cell research that has me hopeful that we might actually solve some really big problems. So that leads me to this very next story that now I'm looking at it seems to be very connected. 3D mini brains accelerate research for repairing brain function. Now, as we have seen that there has been this conference, it was just last month in November in Washington, D.C., where 30,000 brain scientists and researchers attended to talk about all kinds of new ways that they can fix mental disorders and other type of motor dysfunction. This has got to have us a little bit worried. Hospitals, so this is out of ScienceDaily.com, dated December 6th, so this is yesterday, 2017. Hospitals are making mini brains from human stem cells, putting researchers on a fast track to repair the nervous system after injury or disease of the brain and the spinal cord. Researchers have developed a new system to reduce the time it takes to grow these brain models, which will give them the ability to screen drugs and to study what is behind disease-causing mutations more quickly. The Houston Methodist Research Institute is making mini brains from human stem cells that put researchers on a fast track to repair the nervous system. Houston Methodist neuroscientist Robert Krenick, Ph.D., and his team have developed a new system to reduce the time it takes to grow these brain models, which will give them the ability to screen drugs and to study behind what is causing mutations. Their findings are described in an article titled Systematic Three-Dimensional Co-Culture Rapidly Re-Encapsulates Interactions Between Human Neurons and Astrocytes. Like, I never remember that one. In the December 12th issue of Stem Cell Reports, we always felt like what we were doing in the lab was not precisely modeling how the cells act within the human brain. So for the very first time, when we put these cells together systematically, they dramatically changed their morphology, their morphological complexity, size, and shape. They look more like cells that you would see within the human brain. So now we can study those cells in the lab in a more natural environment. Now, we just read about implanting human mini brains into mice a couple weeks ago. I mean, where's this leading, guys? Yeah, of course, it's all about to cure your degenerative diseases of old age and fix your Alzheimer's and your Parkinson's disease and your traumatic brain injury and your spinal column severing that you accidentally did when you tripped in the driveway taking garbage to the curb. I just read a story about that the other day. Some dude who was an athletic surfer tripped in the driveway taking garbage out, and it severed his spinal cord to make him a quadriplegic. I mean, how tragic is that? So why is this important, says Kenrick? He says that cells that grown in a traditional lab culture are put in a flat petri dish, broken up and otherwise manipulated, disturbing their interactions. This results in not being able to reproduce the form, the structure, and the developmental growth of brain cells in the lab, leading to very simplistic looking and immature cells. In the human brain, however, these cells are very complex looking and interact in intricate ways with each other and the environment. New technologies are now focused on 3D culture systems, but an exhaustive time for these studies is not feasible for accelerating discoveries. Normally, growing these 3D mini brains takes months and even years to develop, and we found out that they had the creepiest batch of brain balls yet by letting them grow for a year. And now we have new technologies to premature the cells separately and then combine them together. And we found that within a few weeks, they are able to form mature interactions with each other. So they found a fast forward button. That's got to make you wonder, though, what is that going to do when you try to put that brain into action? They fast forwarded the biology of development. That can't be good. So the length of time to get to that endpoint for studies is dramatically reduced with our system. Krennic's lab focuses on a star-shaped cell type called an astrocyte because they are the key factors in getting the brain's neurons to connect and talk to each other by helping to increase the number and the strength of neuronal connections in the brain and spinal cord. So those must be the things that are developed as you learn and study more, because, if you don't use it, if you lose it if you don't use it. So you'll start noticing, if you haven't been reading for a while, or you haven't been doing research for a while, or writing in a while, that once you start exercising those connections again, you'll start to feel their development. It's really painful at times. They are involved in most neuronal diseases, and also they are responsible for maintaining a healthy nervous system. And with the model of Krennic's team and what they bioengineered, the incorporation of astrocytes accelerated the connections of the surrounding neurons. Krennic's group is the first to specifically engineer astrocytes into these 3D mini brains, and by doing so, this led to an accelerated maturation of both the astrocytes and the surrounding neurons. Introducing them for the first time in this paper, he coined these bioengineered mini brains asteroids. That's pretty funny. What were they calling them? They were calling them organoids. So these are astrocyte organoids, are asteroids, to distinguish them from other 3D sphere cultures known as organoids. Krennic's asteroids contain specific populations of astrocytes where organoids have an undefined number and cell type. And using our system, we can generate mature astrocytes and have them interact intimately with neurons to create a greater extent that has ever been done before. And unlike cells in the brain and the rest of the body, astrocytes have unique properties in humans. It is thought that they are partially responsible for the unique cognitive functions of humans, and they may underlie aspects of human diseases such as Alzheimer's and autism. Ultimately, Krennic is using these asteroids to form functional neural circuits that researchers can then experimentally manipulate. Again, key phrase. That is what our whole planet is right now, something that they are experimentally manipulating to see what happens, for developing treatments and deciphering what diseases tick. Krennic says that they can make induced pluripotent stem cells. Those are those iPS cells from any disease and patient, and then form these mini brains to study the disease process, so they can even make diseased mini brains, as well as screen therapeutic compounds on them to aid in the development of drugs. Within about 5 years, his goal is to use the system to develop clinical trials to improve or regulate a person's impaired nervous system. Well, guys, what do you think of them apples? They want to get in your brain. That is something, if you haven't learned anything over the last couple days in particular, all of these new disruptive technologies seem to be aiming at being able to manipulate our biologies. All right, this is out of SciWorthy.com, December 4th, 2017. Transparent brains are science, not fiction, silly. Researchers have now figured out how to remove lipids, and that would be the fats, and your brain is mostly made of cholesterol and fats, from organs in order to make them transparent for easier study. I don't know if anybody remembers that really horrifying artistic display that somebody had made, and I don't remember where the guy was from, but one of my really good old tech friends had sent it to me, and he went to go see it one time, and then my sister went to go see it. It was somebody who was using cadavers and making them transparent by some unremembered chemical process, and then encasing them in something like polyurethane. So they were these transparent human body sculptures, and some of them I think might have even been in some horrifying looking displays, the way he had posed them. And then they put them into a museum for people to come see. I mean, it's just beyond dystopian nightmares. So innately curious nature of the human race is likely not a surprise to most of us. It is going to lead to our demise. And the saying, curiosity killed the cat, or the human, is one interweaved into many childhoods. At face value, it may be interpreted as discouragement of a person's curiosity and curiosity-driven impulses, and this is soon corrected, however, upon learning the punchline of this colloquial phrase. Curiosity killed the cat, but satisfaction brought it back, and I don't remember ever hearing that second part. And indeed, in a deeper sense, our curiosity and wonder may be the distinctive features setting us humans apart from other animals, or allowing us to be instrumental in our own destruction. The constant quest for why and what ifs has brought the world of invention for things such as airplanes, vaccines, and MRIs. And in a similar vein, researchers at Stanford University asked, can we render organs, such as the brain, transparent, and how would that be accomplished? Well, let's looky. Yes. Hopefully that isn't where we all end up, is in a petri dish as a transparent brain being utilized for much of the brain research that seems to be going on and financed globally. At first, this may seem like a strange goal, so of all of the questions to pursue, why would one aim to turn tissue transparent? To understand the significance of these efforts, we have to delve into the history of microscopy and studies of brain anatomy. The human brain is composed of nearly 7 billion neurons and subdivided into thousands of different neuron types, all wired together to form a functional brain circuit that drives the rest of our bodily functions, from speech and movements to learning and memory. The proper establishment and function of our brain is what, in essence, makes us human. So why are we going to let them in there? Given the astronomical number of neurons in our nervous system, however, studies of brain structures are no easy feat, but Georgie Porgy Church is really helping him out with his barcoding project. And just like trees in a forest, a brief flyover of the forest tells us little about how individual plants work together that reside within the forest. Visualizations of the brain under the microscope reveal a mesh of cells and fibers that tell us little about their cellular connectivity or wiring patterns that make up a functional brain. But remember, we found out optogenetics could do that. To solve this problem, molecular biologists turn to a solution found in nature, and that is fluorescence, ding ding, found in jellyfish. Well, this is some of that FISSIQ technology, I think, that Georgie Church was using in his barcoding. A naturally occurring protein found in jellyfish that makes them fluoresce under certain wavelengths of light. Scientists have extracted these same proteins, and they've placed them into neurons, fluorescently illuminating the structural details of the neuronal cells at the single cell level. And by doing so, different subsets of neuronal outlines can be visualized under a fluorescent microscope for study of their function and wiring patterns. Albeit very useful, the advent of fluorescent imaging requires techniques presented a new challenge, and that is the inability of light to travel through opaque objects. And that means that only the neurons on the surface of the brain can be imaged. So one commonly used method to overcome this limitation is to slice the brain into tiny little super thin sections that are about 1/10 of the thickness of a human hair to allow light to pass through. And I thought for that human online atlas, this isn't the brain atlas, though they were doing it in the brain atlas as well, but there was a human atlas back a long time ago where they did a 3D pass from top to bottom of the human body, and that might have even been on CD way back in the day. I remember reading all about that. I was fascinated and horrified at the very same time. But what they had used was a prisoner who had been sentenced to death on death row, and after he was dead, they sliced him up into 1 trillion little pieces, and honestly, I don't know, I was just exaggerating there, but potentially 1 trillion little micro thin slices, and they cured each one, and they took a high-res photograph of each one, and once they did the entire body, and I think he might have been frozen also, so it could cut through without damaging the cells, and once they had sliced through every single one, they took each image from number 1 to 1 trillion or whatever, and they imaged from top down, so you got an entire view in high definition of the human body. I mean, horrifying, guys. This is like Dr. Mengele type stuff to me, and this is what our future is leading us toward. Experimentation. I don't remember what that phrase was that we read before, but it is. It's about the human being and all of life becoming another item in a petri dish. However, in addition to slicing defects, these methods also restrict studies of neuronal connections on a large scale. This brought researchers to the question presented at the beginning of this article: can you increase light penetration through the brain by increasing its transparency? And oh, how exciting! The answer is yes. The opaque nature of the brain and other organs is introduced by the fats present in our body that are required for life. These authors found that by completely removing lipids from these tissues, various organs can be rendered essentially clear. To do so, they first introduced a mixture of cross-linkers into these tissues through an injection-based system similar to intravenous therapy. These cross-linkers were chosen for their ability to create structural scaffolds along which the non-fats within these organs are attached, and that would be the proteins in the DNA. And following these cross-linking reactions, the brain was placed into a clearing solution made of detergents. I was just thinking about that. I mean, any type of industrial detergent like you would use to wash dishes in a restaurant dissolves lipids. That's why anybody out there who works in food service or who works in any type of industrial environment where you use detergents, always, always, always wear heavy-duty gloves. I'm going to tell you, for all those years in college when I was working in restaurants, I never wore gloves. And I can see that my hands are, they don't look bad, but they are definitely wrinkly, probably more wrinkly than they should be, because I think I actually dissolved the lipids partially in some of my hands, or maybe just the collagen. Anyway, following this process, the brain and other organs disappear before our eyes, quote unquote, and they become transparent. Using these methods, researchers are able to image whole brains with fluorescent microscopy techniques and study the structural details of the neuronal circuits with an intact system with unprecedented detail. So there you have it. Georgie Porgy Church and crew have gotten a boost in their research by being able now to image brains with fluorescence by making them clear. So now, just a little right turn for a minute. I ran across this story this morning. This came out yesterday out of usnews.com. We've talked before about utilizing frequencies to affect the brain in bunches of different forms, whether they be sonic waves or maybe light waves or maybe electrical waves. And we had that whole issue going on where Cuba was accused of being somehow involved in attacking our emissaries, I don't know what you call them, our State Department employees who have been over there. Well, this is interesting. This news story from yesterday states doctors are now finding abnormalities in the brains of Cuba attack victims. Those affected by the invisible attacks in Cuba appear to have changes in their brain's white matter, which affects cognitive function. Now, if you remember, we read yesterday about white matter, and white matter does consist a lot of lipids. An embassy worker in Havana who was subjected to mysterious loud noises and vibrations in an invisible attack last year was found to have developed brain abnormalities, doctors have discovered. These tests by doctors searching for clues to explain what led to the victim's hearing, memory, balance, and vision damage revealed that the workers developed changes to their white matter tracts in their brain to control communication, says several U.S. officials. These findings support a general agreement by government and university physicians who have been researching the attacks. White matter in the brain cells is made up of cells called axons, which connect to one another so nerves can communicate between different regions of the brain. How interesting that they're axons. Weren't we just looking at that? There's all kinds of mad science going on. And how about if they just picked you as a guinea pig that didn't know that they were being pigged? Damage to white matter can impair sensory, motor, and cognitive functions, and the doctors would not say if changes to the white matter were found in all of the victims. The discovery is one of several factors that leads investigators to believe that some type of sonic weapon was used in the attacks. And remember, we've talked about sonic weapons before. Typically, they live within the microwave range, which is the same range as our cell phones and our wireless 802.11 connectivity. And it is a spectrum slice that has allowed the military in the past to be able to do voice-to-skull technology, sending voices into people's heads. They called it the voice of God weapon, or the voice of Allah, as it was utilized in Iraq to get the Iraqis to put their weapons down. It also is the first major physical finding relating to damages incurred by these invisible attacks. You know, and I wondered about that. I mean, beaming microwaves into the brain, how could that not cause some sort of damage? But then it's got to make you wonder. I mean, this is a targeted type sonic weapon where they are pointing at very small, distinct regions of the brain. But how is this microwave frequency, which is part of the entire spectrum that is ubiquitous in our environment, affecting our brains every day as we can't get away from it in a populated area? These attacks, which affected 24 now U.S. government workers and spouses in their Cuban homes and hotels last year, consisted of loud, mysterious sounds accompanied by vibrations, which resulted in hearing loss, visual impairment, and ringing in the victim's ears. And the patients reported hearing sounds in parts of the room, but then that sound was inaudible as they walked just a few feet away. This is unlike normal sound, which spreads in all directions, leading doctors to coin the term for a mystery called directional acoustic phenomenon. Well, that's pretty interesting. I was thinking about ways that they could make that, and I think it is very possible. And there was something from a few years ago that it talked about a weapon that was very similar to that. This led investigators to initially suspect that they were sonic attacks. However, now they think that the sounds may have been the result of something else, as 3 U.S. officials briefed on the investigation, according to AP. Several Canadian embassy workers fell victim to these attacks as well, but American and Canadian officials do not know who is responsible. Cuba continues to deny any involvement, and officials say that there is no evidence to show that such attacks took place at all. Most victims have recovered, and they are back to work after some rehabilitation and treatment, and about 1/4 of them had symptoms that remained for longer periods or even continue to this day. So put on a seatbelt, people, as they are integrating these technologies into every inch of our world. And we are rolling out this Internet of Things that'll be connected via 5G, which again operates in the microwave spectrum. How is that going to affect us biologically? And how is that going to affect our brains? Well, I came across a story a couple days back, and it's been sitting here waiting in queue, and I thought this was a good point to approach this. And it was even more interesting because the guy writing this story looks like he comes back from the days when I spent a lot of time in tech. He is asking, and this is out of the New York Times, how evil is technology? November 20th, 2017, by David Brooks. Not long ago, tech was the coolest industry, and everybody wanted to work at Google, Facebook, and Apple. But apparently, over the past year, the mood has shifted. Some now believe that tech is like the tobacco industry, corporations that make billions of dollars peddling their destructive addiction. We've talked about the addiction to technology before in relation to brain chemicals it produces, and that would be dopamine and that addiction button. Some believe it is like the NFL, something millions of people love, but which everybody knows leaves a trail of human wreckage in its wake. And speaking of football, there have been a lot of stories lately about research that they have been doing on brains of former NFL players after they have died, and they discovered that there's major brain damage that is being done even starting in high school. And now they're talking about maybe banning the game, which I don't see that ever happening since there's billions of dollars to be made. Surely people in tech who generally want to make the world a better place, wink, don't want to go down this road, and it will be interesting to see if they can take the actions necessary to prevent their companies from becoming social pariahs. There are three main critiques of big technology. The first, that it is destroying the young, and I've talked about this a lot because I see it in my own daughter. Social media promises an end to loneliness, but they actually found it produces an increase in solitude and an intense awareness of social exclusion. Texting and other technologies gives you more control over your social interactions, but it also leads to thinner interactions and less real engagement with the world. We also found in a study that it also changes your brain patterns. Your texting and the way your finger is moving is actually changing the way that our brains natively worked back in the 70s and the 80s, pre these technologies. As Jean Twenge has demonstrated in a book and essay, since the spread of the smartphone, teens are much less likely to hang out with their friends, much less likely to date, and they are much less likely to work. 8th graders who spend 10 or more hours a week on social media are 56% more likely to say that they are unhappy than those who they spend less time with. 8th graders who are heavy users of social media increase the risk of depression by 27%, and teens who spend 3 or more hours a day on electronic devices are 35% more likely to have risk factors for suicide, making plans on how to do it. Maybe that's why Facebook just came up with an AI to scan their live video feeds for people attempting to commit suicide live online. Girls are especially hard hit, and they have experienced a 50% rise in depressive symptoms. And I don't want to get into dopamine today. We could save that again for another show, or just search Before the First Cup and Dopamine on YouTube, and you'll find most of the shows I did with all the links and all the different psychological changes that this addiction and this pumping up of dopamine in the brain causes to children. The second critique of the tech industry is that causing this addiction on purpose to make money is what they are doing. Tech companies understand what causes dopamine surges in the brain, and they lace their products with quote-unquote hijacking techniques, and we are being hijacked from every single direction by tech that lure us in and create what they are calling a compulsion loop. Snapchat has Snapstreak, which rewards friends, and Facebook has a thumbs up button, for every single snap that each other every single day, and thus encourages the addictive behavior. News feeds are structured as bottomless pits so that one page view scrolls down to another and another forever. Most social media sites create irregularly timed rewards. You have to check your device compulsively because you never know when a burst of social affirmation from a Facebook like might come. A third critique is that Apple, Amazon, Google, and Facebook are near monopolies that use their market power to invade the private lives of their users and impose unfair conditions on content creators and small competitors, and also find out ways how to monetize all that information they've collected about you. The political assault on this front is gaining steam. The left is attacking tech companies because they are mammoth corporations. The right is attacking them because they are culturally progressive. I don't know about that. And tech will have few defenders on the national scene. Obviously, the smart play would be for the tech industry to get out in front and clean up its own pollution. There are activists like Tristan Harris of Time Well Spent who's trying to move the tech world into the right direction. There are even some good engineering responses. And in an app called Moment to track, I use an app called Moment to track and control my phone usage. This big breakthrough will come when tech executives clearly acknowledge the central truth that their technologies are extremely useful for tasks and pleasures that require shallower forms of consciousness, but not for learning, and not giving to every child in school to addict our children to the machine before pubescence. But they often crowd out and destroy the deeper forms of consciousness. People need to thrive and to think deeply about things. I'm going to add. Online is a place for human contact, but not for intimacy. Online is a place for information, but not for reflection. It gives you the first stereotypical thought about a person or a situation, but it's hard to carve out time and space for the third, 15th, and 43rd thought about them. Online is a place for exploration, but it discourages cohesion. It grabs control of your attention, and it scatters it across a vast range of diverting things, and that is very true. Oh, look, it's a chicken. I find out when I'm working and I'm trying to figure out or research something online or write something down, and I have too many tabs open, it really spazzes my eyes out and gets my brain just short-circuiting because I can't focus on anything. That's a very bad thing, and technology does that to everybody. We read a story just recently about even just having your cell phone sitting on a table while you're trying to do a cognitive test or task causes people to be distracted way more times than if the phone was out of sight, out of mind, in another room, and that was even if the phone wasn't on. It gives you the first stereotypical thought about a person or a situation, blah, blah, blah. But we are happiest when we have brought our lives to a point when we have focused our attention and our will on one single thing wholeheartedly with all of our might. And guys, that is exactly the way to accomplish things, is to give laser focus of your attention and your willpower to make it the one single thing you're going to put all of your energies into. Then you actually accomplish something. So this whole takeover that is happening, our technocratic future that is coming, is all being accomplished because they have diverted our attention and our might, our focus from making this a better world and sucking us into that deep black hole, so we are now stuck in the event horizon. Rabbi Abraham Joshua Herschel wrote that we take a break from distractions of the world, not as a rest to give us more strength to dive back in, but as the climax of living. And yeah, like we go to relax. Our relaxation is that dangling carrot that we work toward. But the seventh day is the place and time with which we build. It is made of soul, of joy, of reticence, he says, and by cutting off work and technology, we enter a different state of consciousness, a different dimension of time, and a different atmosphere a mine where the spirit's precious metal can be found. And that's very true. Anyone who has ever done a full disconnect, at least even for a day, gone out to the woods and enjoyed nature without looking at their phone, without necessarily even having connectivity, and I'm lucky that I know a place like that where I can go and there is no cell phone connection at all, and I still have some of the accoutrements of modern day living, like a toilet. It's a wonderful feeling, and I start to laugh because I think that Skynet sometimes starts to freak out when I drop off the grid. Where'd she go? But he's absolutely right. When you focus your attention and your will on something in particular, and you are not distracted by the technologies that are around you, the world is a very different place, and it quiets the brain. Imagine if instead of claiming to offer us the best things in life, technology merely saw itself as providing efficiency devices, and its innovation can save us time on lower level tasks so we can get offline and then experience the best things in life. Yeah, imagine that, but that isn't the way it works. Imagine if tech pinched itself that way. What if it would be amazing to show the realism and especially the humility, which these days is the ultimate and most disruptive technology. Yeah, let's make a big program to disconnect and reconnect with your fellow humans. All right, well, we're going to hit the end of the show with this one. IEEE Spectrum, November 30th, 2017. Internet addiction creates imbalance in the brain. Well, we already knew that. New research has linked internet addictions with a chemical imbalance of the brain in a small study presented today at the annual meeting of Radiological Society of North America in Chicago. 19 participants with addictions to phones, tablets, and computers exhibited disproportionately high levels of a neurotransmitter that inhibits brain activity. The good news, after 9 weeks of therapy, the participants' brain chemicals normalized and their screen time decreased. So you got to go off-grid for 9 weeks, it seems. CO, who is the professor of neuroradiology at Korea University in Seoul, who presented this study, and his colleagues discovered that brain chemical imbalances using MRI and the imaging technique that detects changes in certain metabolites in the brain. The tool showed that the participants with internet addictions compared to a control group had elevated levels of gamma aminobutyric acid, short for or long for GABA, which this is the first I'd ever read about GABA in relation to this, which is a neurotransmitter that has been linked to other addictions and psychiatric disorders. All right, guys, have an awesome Thursday.